Welcome to viewers. In this video we are discussing how to convert recurring decimals into fractions using the properties of geometric progression. So let's quickly remember the sum of infinite terms of a GP. Say this is a GP, suppose AR square, AR cube, A into R to the power -1 and so on. Now if r lies in between 1 and -1, then we find that sum of infinite number of terms of this series will be given by a divided by 1 minus r. Here r lies in between 1 and -1. That means r is a fraction. Say for example r equal to suppose -1 by 3, 1 by 7, 1 by 10, etc. Right? Now let us recall the decimal expansion of a decimal number. Say for example 212.05, suppose. So in terms of place value you will write 2 multiplied by 100 plus 1 multiplied by 10 plus 2 multiplied by 1 plus, now what is the place value of 5 here? The first place after decimal is called 10th place and second place is called 100th place. So we will write 5 divided by 100, 5 upon 100, 500, right? Similarly, say for example 7.201, suppose. So we will write it as 7 multiplied by 1, 7 is in 1's place, 2 is in 10th place, 2 divided by 10 plus 1 in 100 place, 1 by 100, right? Similarly, say for example 13.1234, suppose. So you will write it as 1 multiplied by 10, 3 multiplied by 1 plus this 1 is in 10th place, 1 by 10. This 2 is in 100 place, 2 by 100. This 3 is in 1000 place, 3 by 1000. Then 4 upon 10,000. Right. Now let us recall the recurring decimal fractions. Say for example 0.3 recurring. What does it mean? This means 0.333, and this means there will be infinite numbers of 3's after decimal. So how will you write it in expanded form? You can write it as 0 plus this place is in 10th place, 3 by 10. Next 3 is 3 by 100. Next 3 is 3 by 1000, 3000. Next 3 is 3 10,000 and so on, right? Now let's say we want to convert this into common fraction. How do we do it? So you will find that 3 is common here, so you can write it as 1 by 10 plus 1 by 100 plus 1 by 1000, 1 by 10,000 and so on. So 0 plus 3 multiplied by, so this is clearly a geometric progression. You can write it as 1 by 10, 1 by 10 square, 10 cube, 1 by 10 to the power 4 and so on. So what is A here? If you treat this as a geometric progression, here A means here 1 by 10, and what is R here? A2 divided by A1, second term 1 by 10 square divided by 1 by 10, so it is 1 by 10. Common fraction, common ratio is 1 by 10, so it is less than 1. So we find that R lies in between -1 and 1. So what is the sum of this GP series? So you will find that the sum of this GP series is 0 plus 3 multiplied by a divided by 1 minus r. Here a means 1 by 10, r means here 1 minus 1 by 10. So let us simplify this. 3 multiplied by 1 by 10 means 3 by 10 divided by, this becomes 9 by 10. So we will write it as 3 by 10 multiplied by 10 by 9. So after simplification it becomes 1 by 3. So this is the fractional form of 0.3 recurring. This is how you can convert a recurring decimal into a common fraction using the properties of geometric progression. So let's do one more example to clear our concepts. Let's take one more example, say 2.03 recurring, suppose. Now 2.03 recurring means 2 plus, you can write it as 0.30333, etc. Here 3 is recurring, so you can write it as 2 plus 0.03333, etc. Again you can write it as 2 plus, you can write it as 0.03 plus 0.003 plus 0.0003 and so on, right? If you add this, again you will get this number, right? So let's say you can write it as 2 plus 0.03 means you can write it as 3 by 100, 300. This you can write it as 3 by 1000. This you can write 3 by 10,000 and so on. So let's take 3 common here. 1 by 100, 1 by 1000, 1 by 10,000 and so on, right? Now you can write it as 1 by 10 to the power 2, 1 by 10 to the power 3, 1 by 10 to the power 4 and so on. Now this series is a GP series. Here you see, if you treat this as a first term, if a equal to suppose 1 by 10 to the power 2, what is r here? R here means a2 divided by a1, second term divided by first term, 1 by 10 to the power 3 divided by 1 by 10 to the power 2. So answer is 1 by 10. Therefore r lies in between 1 and minus 1. R is a fraction, common ratio is a fraction, it is less than 1, greater than minus 1. So it's an infinite GP series. You can find the sum of this series. So how to find this? 1 by 10 square, 1 by 10 cube, 1 by 10 to the power 4 and so on. So sum of this series will be a divided by 1 minus r. Here a means 1 by 10 square, 1 minus r, r means 1 by 10. So it is 1 by 10 square divided by 9 by 10. So it is 1 by 10 square multiplied by 10 by 9. So it is 1 by 90, right? So sum of this series is 1 by 90. Therefore 2.03 recurring equal to, so we will get 2 plus 3 multiplied by this series is 1 by 90, 1 by 90. So it is 2 plus 3 by 90 means 1 by 30. So it is 30, 32 is a 60 plus 1, 61. So this is the fractional form of this recurring decimal. This is how we can convert recurring decimals into common fraction. Thank you for watching this video. Bye bye.